All right, here we go. The first thing we're going to talk about today are quartiles. And you might guess this from the root of the word. In quartiles, we have Q-U-A-R-T. And if you think about quarters, there are 4 quarters in a dollar. There are 4 quarts in a gallon. And so what quartiles do is quartiles cut a data set into 4 equal parts. So imagine we have a data set and we want to cut it into 4 equal parts. Well, if I had a candy bar and I wanted to cut that into 4 equal parts, I don't think I would try starting on the left and cutting it into 4 equal parts. That would be really hard for me to do. Instead, first I'd cut it in half, and then I would cut those halves in half. And that's how I would get my 4 equal parts. First thing I would do is cut it in half, and then cut it in half again. And that's exactly how we are going to cut a data set into 4 equal parts. That's how we're going to do our quartiles. And the first thing we're going to do is cut the data set in half, and we already know how to do that because that's what the median does. So here where we cut the data set in half, that's our median. And then when we go to cut it in half again, we are going to take the lower half of this data set and cut that in half. And when we do that, we're finding the median of the lower half of the data set, and we're going to call that the lower quartile, also known as the first quartile. Those mean the same thing. So lower quartile or first quartile mean the same thing, and that's the median of the lower half of the data set. And then similarly, on the upper half, we have this upper half of the data set up here that we're going to cut in half. So we're going to find the median of the upper half of our data set. And when we do that, we call that position the upper quartile, which is also known as the third quartile. So that's our upper quartile. And that's how we cut this data set into 4 equal parts. And when I say equal parts, it means the number of data points that, well, we already know the median cuts it in half. It means the number of data points back here is the same as the number of data points over there. And then when we do this with quartiles, now we have 4 pieces, and each one of those pieces contains the same number of data points. Any questions on anything we did there? Basically, definitions here. Lower quartile, upper quartile are the new terms for us. All right. 5-number summary. If we want to find the 5-number summary of a data set, what those 5 numbers are that make up the 5-number summary are the lowest data point, the highest data point, the median, and then the new things are those 2 quartiles we just talked about, the lower quartile and the upper quartile. And so we need to find those 5 numbers if we're going to find the 5-number summary, and that'll be the highest, the upper quartile, the median, the lower quartile, and the lowest. That's what I'm after for this particular data set right there. Before I do any of this work, I know I need to find a median eventually, so I'm going to write this least to greatest. So here goes. Let's see. Got 2, 3, 4. Keep an eye on me here. Don't let me miss anything. 5, 7, 8, 11, 13, 15. I think that's all of them. Let's see, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 data points. Let's make sure I wrote down 9 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Doesn't guarantee I wrote down the right numbers, but I feel pretty good about the fact that I wrote down the correct numbers. I just needed to make sure I have the correct number of numbers, which I do. And so I have 9 data points here. That's important to hear in just a minute, but if I want my 5-number summary, 2 of those come really easily. The highest is 15 and the lowest is 2. So the highest is 15 and the lowest is 2. All right, keeping going, finding this 5-number summary, I'll need the median next. I'm not going to try to cut this in 4 equal parts going left to right. First, I'm going to find the median and cut this in half. And a little bit of review here, but I have 9 data points, which is an odd number. So there will be one right in the middle. And there are 8 other data points. 4 will be lower than the median, 4 will be higher than the median. So when I section this thing off, 4 lower, 4 higher, my median is just that 7 right there in the middle. So my median is 7. Again, little review, just a reminder, this median that's right here in the middle, that's not in the upper half, that's not in the lower half, it's just the median. That's it. So it's all by itself there. It's not in the upper half, it's not in the lower half. So when I go to find this lower quartile here, all I'm looking at is the lower half of the data set. The median is not going to be a part of it. It's important to make note of that. We want to make sure we handle the median carefully. All right, so when I'm looking for this lower quartile here, that's going to be the median of the lower half. Here's my lower half, so I need the median of that. And when I look at the lower half now I just have 4 data points. And that's an even number. So I won't have a number right in the middle. Instead, what I'll need to do is section this off so that I have these 2 and these 2, and then define the median. Again, little review. The median of the lower half, I need what's halfway between those 2 numbers. You could probably eyeball it and say, well, halfway between 3 and 4 is 3.5. Or if you want to, you can do 3 plus 4 over 2, because we're finding the mean of those 2 numbers. 7 over 2, and sure enough, that's 3.5. So the median of the lower half, which is the lower quartile for my data set, is 3.5. 3.5 is not one of the data points in this data set, but that's okay. Just like the mean doesn't have to be a data point, the median doesn't have to be a data point, the lower quartile doesn't have to be a data point either. It's an indication of where, we cut the data set into 4 equal parts. That's where we would cut it. Let me know if you have any questions about anything we're doing. We're about to find the upper quartile, and we're going to use that exact same process over there. Because the upper quartile is going to be the median of the upper half. And here again, we have 4 data points. So there won't be one right in the middle. But we can section that off and then find the 2 data points that are closest to the middle, 11 and 13. We want the mean of those. Many of you are probably very comfortable saying, well, then it's 12, and you'd be right. If you're more comfortable saying, I'd rather write this down and do 11 plus 13 over 2, that's 24 over 2, and that's 12. So that is the median of the upper half, which means it's the upper quartile of our data set. And so our 5-number summary is right here in this box. The highest is 15, the upper quartile is 12, the median is 7. The lower quartile is 3.5, and the lowest is 2. Let me know if you have any questions about how to find a 5-number summary before I have you try one. All right, outstanding. I want you to find the 5-number summary for that data set. I'm gonna make a poll for this. My poll is just gonna be the lower quartile and the upper quartile. I'm thinking if you found those correctly, then you've probably found all 5 correctly. We'll talk through all 5, but the poll's just gonna be the 2 quartiles. So lower quartile is the first number, upper quartile is the second number. Finding the 5-number summary is definitely the kind of question you could expect to see on a quiz or on an exam. So make sure you're comfortable um, not only finding the median, but finding the entire 5-number summary. Let's go another 30 seconds on this, and then we'll talk through it together. If you need more time, just let me know. If you don't see your answer there, pick the one that's closest to it, and that way I'll know you've had enough time to work on. All right, let's see how we did on this one. Unanimous. Very good. We got a lot of that last class, so more of it today would be great. All right, so as we take a look at this one, the 5-number summary that I'm supposed to find is going to be the highest, the upper quartile, the median, the lower quartile, and the lowest. Before I find any of those, the first thing I'll do is write these from least to greatest, which will be, let's see, 11, 14, 17, 21, 26, 27. All right, so I have 6 data points. That's an even number. So when I go to find the median, there's not going to be one right in the middle. Just sort of making a mental note of that ahead of time. The highest and lowest come pretty easy. The highest is that 27 and the lowest is the 11. Next, we need the median. 6 data points, so there won't be one in the middle, and 3 data points will be below the median, 3 data points will be higher. So when I section that off, I don't have a data point right in the middle, but my median will be the mean of the 2 closest to the middle. And so that's 17 plus 21 over 2, which is 38 over 2, or 19. And if you saw halfway between 17 and 21 is 19, that's just great. So our median's 19. Now we need the quartiles. Those are the new things that are here, and important to note that the median is not in the upper half, not in the lower half, but 11, 14, and 17, all of those are in the lower half. You can see where we've sectioned off this lower half of the data set. All 3 of those are in the lower half. So this number that we kind of use to help us find the median, there might be a little bit of an instinct to say, I don't think I should count that in the lower half, but you do count that in the lower half. It's the median itself that's not in either half. The 17 is in the lower half, the 21 is in the upper half, just to make sure that's clear. And now finding the lower quartile is pretty simple, because as we look at this, we can see, well, there's only 3 data points. So the one in the middle is a lower quartile. In the upper half, there's 3 data points. So the one in the middle is the upper quartile. And there's our 5-number summary: 11, 14, 19, 26, 27. Let me know if you had any difficulties with that, if you have any questions on that. The poll went great, so I feel pretty good about it. But if there's anything you want to ask about, don't hesitate. All right. There's a type of graph we haven't looked at yet that the 5-number summary is really useful for. We use this 5-number summary to make a graph. And what that graph is called is a box and whisker plot, or for short, just a box plot. So box plot is just a shorthand way of saying box and whisker plot. What we're looking at there is the 5-number summary for that first data set we talked about, where the lowest was 2, lowest quartile 3.5, median 7, upper quartile 12, and highest is 15. And we're going to use that 5-number summary to draw a box plot. The first thing I'm going to do is make myself sort of a scale down here. Essentially, it's just a number line that we're going to use to help us draw our picture. And because I can see my lowest is 2 and my highest is 15, I'm going to go from 0 to 20, just to make sure I have a little cushion on both ends. All right. I'm going to draw a box plot, and here's how that goes. The box part of a box plot goes from the lower quartile up to the upper quartile. So I need my box to go from 3.5 up to 12. Well, I drew this number line down there as my scale. I better put some labels on here, make this a little easier on myself. Okay, now I'm going to draw my box of my box plot. The box starts at the lower quartile that's 3.5. It doesn't have to be perfect. There's 3.5. And it goes all the way up to 12, which will be about here. And so this is the box in my box and whisker plot. There's my box. And you could label the lower quartile and upper quartile if you want to. You don't have to, but you can. And then the median is an important number. You can see the median is going to be inside the box somewhere. We just draw a vertical line where the median goes here at 7. And so inside the box, I've got my median. The ends of my box are the lower and upper quartiles. And then the whiskers. It is a box and whisker plot after all. I'll put a line down here at 2 where my low point is and put a whisker. And I'll draw a line over here at 15 where my high point is, and I'll draw a whisker. And so I have the lowest data point, the lower quartile, median, upper quartile, and the highest data point. And so what we've done here is we've taken this 5-number summary and we've used it to draw a box plot. What's the value of this box plot? It's an excellent question. I can tell you they are fantastic for comparing 2 data sets with each other. It's easy at a glance to see where was the highest, where was the lowest, what is the median of these 2 data sets. We're not going to do a ton of that because I'm just more interested in if you can read a box plot and understand what it says. A key here, and before I start asking you some questions, I'm going to emphasize this idea. Somebody tell me, what do the quartiles do? Somebody remind me, what do the quartiles do? And it doesn't have to be perfect. It's just, what do the quartiles do? All right. Very good, Jennifer. Perfect, Katie. Yeah, exactly right. And Jalen, I hope you're right in line with those two. Cuts a data set into 4 equal parts. So what that means is that the same number of data points is in each one of these pieces of my box plot, because those are the quartiles. This quartile and the median there. We've cut the data set into 4 equal parts. That means 1/4 of the data is here, 1/4 of the data is here, 1/4 of the data is here, and 1/4 of the data is here. 4 equal parts. Any questions about what we just decided there before I start asking questions? All right, very good. Here goes. So a factory that makes batteries did some testing, and they tested 250 batteries, and they kept track of how long the battery would live before running out of juice. And what they did was they compiled all this data from these 250 batteries, They found the 5-number summary, the lowest, the highest, the median, the lower quartile, and the upper quartile, and they made this box plot. My question to you is, reading that box plot, and I'm going to make a poll for this, did more batteries last less than 16 or more than 24 hours? And like I said, I'm going to make a poll for this, so just hang on for a second. Okay, just a reminder of what that question is. In this thing, when they did these 250 batteries and they compiled all this data and they made this box plot, did more batteries last less than 16 hours, or did more batteries last more than 24 hours? So that's the question. Were there more batteries that lasted a really short lifespan, or more batteries that lasted a really long lifespan? And really, this is just about reading a box plot. So there's no calculation that you're going to do here. And so we'll go, let's go another 20 seconds, and then we'll talk about this one. All right, let's see where we are on this one. Okay, we are no longer unanimous. We are spread all over the place on this one. This is one I didn't expect to be unanimous. So let's take our time as we talk through this one. Let's see. What do quartiles do? They cut the data set into 4 equal parts. So when I look at this box plot, what I see here is my lowest, my lower quartile, my median, my upper quartile, and my highest. And the quartiles cut the data set into 4 equal parts. What you all agreed to just a minute ago is that 1/4 of the data is here, 1/4 of the data is here, 1/4 of the data is here, and 1/4 of the data is here. Any issues with any of that? Okay, so if 1/4 of the data is in each one of those, that means there's an equal number of data points in each one of those chunks, which means less than 16 hours right here has the exact same number of data points as more than 24 hours over here. Did more batteries last less than 16 or more than 24? They're the same, because 1/4 of the batteries are in there and 1/4 of the batteries are in there. It's very counterintuitive. It's very hard to want to accept the idea that, wait a minute, you're telling me that this big giant chunk back here has the same data points as this little tiny piece right there? Yes, because that's what quartiles do. Quartiles cut the data set into 4 equal parts. What this means is the data points over here are more spread out. The data points in here are all smashed together. But what we know is they're the same number of data points in each one of these pieces. 1/4 of the data is back here, 1/4 of the data is over here. So Did more batteries last less than 16 or more than 24? It's the same number of batteries in each piece. That's the kind of thing that that you could consider a trick question, except for the fact that we've talked about it a lot now. So not anymore. Now you're like, oh yeah, quartiles, cut the data into 4 equal parts, same number of data points back here as there are over here. Let me know if you're not okay with that, and you're totally excused for thinking, well, there's gotta be more data points here than there are over here. I mean, look how much bigger it is. But that's not what this is about. What this is about is quartiles cut it into 4 equal parts. Same number of data points. Back here, they're just more spread out. Over here, they're all smashed together. Any questions on that? Are we good on this? All right, a couple more box plot questions. Same box plot, same 250 batteries. Now my question to you is, what percent of these batteries lasted less than 24 hours? I'm going to make a poll for this and have you tell me. Essentially, what we're looking at here is ways that box plots can be useful for us. So there were 250 data points from these batteries. Somebody took those 250 data points and found the 5-number summary. What they did was they said, well, I'm going to arrange these from lowest to highest. I'm going to find the lowest and the highest. The lowest was 10, the highest was 25. We can see that. Then I'm going to find the median, the upper quartile and lower quartile, and then I'm going to draw my box plot. And so they did that. They drew the box plot. And then because quartiles do a certain thing, that gives us information about the data. And we've only talked about this in terms of fractions so far, where 1/4 of the data is in each spot. So I suppose I should say it 25% of the data is in each piece, since this is a question about percent. I think you can probably make that leap, but just in case. We'll go another 20 seconds on this one, and then we'll talk about it. All right, let's see how we did. Okay, not unanimous, but definitely strong agreement here. That's really good. I think we've turned a corner. Let me know if you see something that you're not sure of. But what percent lasted less than 24 hours? Well, now we've kind of got our feet on the ground with the idea that 1/4 of the data is in each one of these pieces, regardless of how big that piece is, which means 25% of the data is in each one of these pieces, regardless of how big or small the piece is. So 25% of the data is in each piece of this, because that's what quartiles do. And what percent of the batteries lasted less than 24 hours? Well, here's the 24-hour mark. So less than that is everything back here. So that would be 25 plus 25 plus 25. 75% of the batteries lasted less than 24 hours. Only 25% of them lasted more than 24 hours. Let me know if you have any questions on that. I feel like we're in a much better place now with 25% is in each region, regardless of how big or small it might be. Okay, this question said, what percent lasted less than 24 hours? I'm going to ask a very similar question next with one small but important change. Same data, same box plot. This time the question says, there were 250 batteries involved in this study. How many batteries lasted between 16 and 24 hours. So I'll set up a poll for this. And now the question isn't what percent, it's how many. So very similar to the last question in that what a box plot does is it tells us that 25% of the data is in each piece. Last time it asked for percent. This time it asked how many batteries lasted between 16 and 24 hours. We can go another 20 seconds on this, and then we'll talk through. All right, let's see how we did on this one. Okay, we're kind of split there. Two of those have something in common though, so I think we can clean a lot of this up really quickly, but let's go ahead and take a look. So the last question said what percent. This one says how many. So let's take a look at how we're going to answer this question. We've got a box plot here, and what a box plot tells me is that there is 25% of the data in each one of these pieces, because that's what quartiles do, that's what a box plot does. And so here it says how many lasted between 16 and 24 hours. Well, 16 is right here, 24 is right here, so 50%. I understand, Summer, that happens sometimes. So 50% lasted between 16 and 24 hours, but that's not our answer here. If this question said what percent lasted between 16 and 24 hours, we'd say 50 and be done. But it didn't. It said how many of the batteries? Well, there were 250 batteries total, so 50% of those 250 batteries. It's half of them, so you could just divide by 2 and get 125. If it wasn't 50%, if you wanted to look at this from a standpoint of a percent problem, which is something we'll do later on this month, but 50% written as a decimal would be 0.5. Of is a word that tells us to multiply, and 0.5 times 250 would also get us to 125. So while 50% is a really important number here, and it means you did something right, our answer for how many batteries would be 125. Let me know if you have any questions on that before we move away from box plots. Okay. A box plot cuts the data set into 4 equal parts with 25% in each spot. We know that half the data is going to be above the median, half the data is going to be below the median. If we wanted to stratify the data set even more specifically than that, something called percentiles. And we're not going to spend much time on percentiles. They're not going to be a focal point for us, but I do want to mention them because eventually as a teacher, you may see percentiles, and I just want to make sure you know what percentiles represent, what they mean. Percentiles give the relative position of a data point within the data set. And an example of that would be the median is at the 50th percentile. So, if we have our entire data set here, the median is at the 50th percentile. It's halfway. And what that 50th percentile means is that the median is above 50% of the data that's in the data set. Along those same lines, a data point that's at the 88th percentile is above 88% of the values in the data set. So if you have a data point that's over here at the 88th percentile, what that means is it's above 88% of the data points. And how that could come into play for you is you have a student who takes a standardized test and they score at the 91st percentile. It doesn't mean they got 91% of the questions correct. It's not about that. It means relative to all the other students who took the test, they scored better than 91% of them. That's what a percentile tells us. So it's not a raw percentage. It's not, if you're at the 73rd percentile, you didn't get a 73% on the test. That's not what it means. What it means is you did better than 73% of the people who took the same test as you. So that's what percentiles are, and that's what they mean. Like I said, not a huge focus for us in this course, but I want to make sure you've at least heard the word and know what it means. Very similar to quartiles, very much related to quartiles. It's just instead of 25, 50, and 75, we can be even more specific if we use percentile. Okay, we had three main topics today. Quartiles, box plots, and weighted averages. Up next, weighted averages. Probably a very relevant weighted average type of problem for you is grade point average, calculating the grade point average. And we look here and we see that this particular student is taking a 5-credit math class, a 1-credit science class, and a 3-credit history class. And we can see what their grades are. If we want to calculate the grade point average for this student, there's a process involved. And the way we're going to go about this is using, it's a formula for how grade point averages are calculated. And grade point average is found by taking the number of grade points that a student earns and dividing it by the number of credits that a student is taking. Okay, wonderful. I can see really easily here, 5, 6, they're taking 9 credits. But grade points, where does that come from? Well, every grade that you earn has a certain value attached to it. An A is worth 4 grade points per credit. A B is worth 3 grade points per credit. A C is worth 2 grade points per credit, and so on. Now we can kind of see right here, this student has a B+. How does that work? Well, just sort of to fill in these gaps over here, an A- would be worth 3.7 grade points per credit. I lost my connection, so it'll be right up there. And then, so a B+ splits that difference and is worth 3.3 grade points per credit. So pluses and minuses work in here just the same as any other grade would. And if I want to find the GPA for this student, then one of the things I need to find is how many grade points did this student earn? And here's how we'll do that. So they were taking a 5-credit class and they got an A in this 5-credit class. Since they got an A, they earn 4 grade points per credit. So what we're going to do is we're going to take the number of credits and multiply by the number of points per credit. So 5 credits times 4 grade points per credit, they earn 20 grade points for that math class. If you see something that you're not sure of, you don't understand where it came from, don't hesitate to ask. What we're taking is the credits they took multiplied by the points they get for the grade they earned. And we multiply those. They have a 1 credit science class and they got a C in it. That C is worth 2 grade points per credit. So for that class, it was a 1 credit class multiplied by 2 grade points per credit. They earned 2 grade points for that science class. And then finally, this 3 credit history class, they got a B plus. It's like a B plus is 3.3 grade points per credit. So a 3 credit class times 3.3 grade points per credit. Let's see, 3 times 3.3, that's 9.9 grade points for that class. So now we have to figure out all together. How many grade points did they earn altogether? So we need to add these three. Let's see, 20 plus 2 plus 9.9. They earned 31.9 grade points. So what their grade point average would be is the number of grade points, 31.9, divided by the number of credits, 5, 6, 7, 8, 9. 31.9 divided by 9. This student's grade point average would be 3.54, 44444. Looking all the way back at the beginning of this, we were told to round to the nearest hundredth, so we'll find the hundredths place, look one space to the right. That's 4 or lower, so we'll round this down to 3.54. So this student has a 3.54 grade point average. Are there any questions on any of the steps we did there before I have you try one? Outstanding. Okay, here goes. Just a reminder, an A is worth 4 points per credit, a B is worth 3 points per credit, and a C is worth 2 points per credit. I want you to find the GPA for that student. I'll set up a poll for this one. A grade point average is a beautiful example of the type of problem that involves a weighted average. So this is a really good example of a question that you might see on a quiz or an exam as a way to sort of do a weighted average type of question. If you get something that is not shown, pick the one closest to yours. That way I'll know you've had enough time. Otherwise, let's go another 20 seconds and then we'll talk about this one together. All right, let's see how we do. Not unanimous, but strong agreement. Okay, strong agreement down there. That's usually a good sign. All right, let's take a look at this. And the first thing I want to say is what you don't want to do here is say, well, I look at their grades and I see they have an A, a B, and a C. So if I just average those together, that's a B average, and a B is 3.0, so their grade point average is 3.0. That's fine if every class is worth the same number of credits, but in this case, they're not. And the thing that makes this a weighted average is this 5-credit math class is going to count the most. The 4-credit science class is going to count the next most. And, the history class counts, it's worth 2 credits. But of these 3 classes, it carries the least amount of weight because it's only worth 2 credits. The science is worth 4 and the math is worth 5. If they were all the same number of credits, you could go an A, a B, and a C, averages out to a B, it's 3.0. But since they're not all the same number of credits, we can't do that. We want to make sure we take the weight of each one of those classes into account. Remembering that GPA is grade points divided by credits, we'll have to figure out how many grade points this student earned. So the number of grade points earned. Well, let's see. What we've got here is we have a 5-credit B. A B is worth 3 points per credit. That's why we multiply. So a 5-credit class times 3 points per credit, that's 15 grade points for the math class. 4-credit science class, a C is worth 2 points per credit. So 4 credits times 2 points per credit, that's 8 grade points earned in that science class. If you see anything that you're unsure of, it doesn't make sense where those numbers came from or why we did a certain step, make sure you ask. Finally, this 2-credit history class, they got an A in it. So that's 4 points per credit. So 2 credits multiplied by 4 points per credit, they got 8 points for that history class. So let's see then, adding those together, 15 plus 8 plus 8 is 31 grade points earned. 5 and 4 is 9, 10, 11 credits. So 31 grade points divided by 11 credits is 2.81818. That keeps going. We were told to round this to the nearest hundredth. So we'll find the hundredths place, look one space to the right. That's 5 or bigger, so we'll round this up to 2.82. So the grade point average for that student was 2.82. First thing, I want to give you a chance to ask any questions about anything we did there to calculate that grade point average. And then the second thing I want to do is talk about the idea that this is a weighted average. So we've got an A, a B, and a C, but okay, the B is right in the middle. But if we look here, this 4-credit C is going to pull their grade down more than this 2-credit A is going to pull it up. It's the weight of this 4-credit class that pulls it down. It would have been 3.0 if they were all the same credits, but this carries more weight than the history class. And so that C pulls them down a little bit from 3.0, and that's why we end up with a GPA that's less than 3.0. If it would have been the history class worth 4 and the science class worth 2, it would have pulled it up from 3.0. Let me know if you have any questions about that idea, because that's where the weight of this weighted average comes in. Fantastic. Okay. Here's a weighted average question that is a new situation, but a very familiar type of problem because it's a lot like something we did last week. Over the course of her first three semesters at college, Amy had taken 50 credits and earned a GPA of 2.35. She's taking 16 credits this semester. In order to bring her overall GPA up to 2.5, what GPA will she need this semester? And this could be done with trial and error, but we're not going to go about it that way. This problem is going to be very similar to, I'm trying to think of the name in the example. I think it was Carmen, maybe, but she or Josephine had taken a certain number of exams and had one more exam to go. How many points does she need on that last exam? This question is very similar to that, just in a new situation. So let's see, Amy's taken 50 credits and has a GPA of 2.35. Well, wait a minute. The way GPA is calculated, GPA is grade points, divided by credits. So in this formula, if I know two of the three pieces, I can find the third piece. And so where Amy is right now is, let's see, her GPA is 2.35, and I'm just using this formula down here. Her GPA is 2.35. She's taken 50 credits. I don't know how many grade points she has right now, but I can figure it out. I just need to multiply both sides by 50, and I'll know how many grade points she has right now. These cancel. Hopefully this is looking really familiar from last week. If not, you can tell me. So 50 times 2.35, that's 117.5. So that's how many grade points Amy has right now. Well, what she's going to need is she wants to have a 2.5 GPA. And then here's the important part of this, just like it was last week. How many credits will she have taken after this semester? Not quite as straightforward as last week, but the same idea. Excellent, Jennifer. Very good. She's taken 50 credits so far. She's taking 16 more this semester. So the 50 credits she's had so far, plus the 16 she's going to take this semester, is going to put her at 66 credits when this semester is over. That means we can figure out how many grade points she needs by multiplying both sides by 66. These are going to cancel. So the number of grade points she's going to need, and I'll put GR in front of there, 66 times 2.5, 165. So, and please tell me if there's anything in here that's happening that you're not really sure of. I hope it feels really familiar and comfortable from what we did last week. It's just the numbers aren't quite as soft as they were last week. This is a little more involved. But right now, she has 117.5 grade points. In order to have a 2.5 GPA, she's going to need to have 165 at the end of the semester. So she's going to have to bridge that gap. So she's going to have to earn 165 minus 117.5 this semester. She's going to have to earn 47.5 grade points. One more thing we've got to do here that we didn't have to do in the problems we looked at last week, because it says here, in order to bring her GPA up to 2.5, what GPA will she need this semester? So we have to find the GPA she'll need this semester. Let's see, right back here to this formula again. The GPA that she's going to need is going to be the grade points she needs to earn divided by the credits. So this is one extra step that wasn't involved in the problems we were working on last week. But that's okay. The GPA she's going to need this semester then, well, she's going to need to earn those 47.5 grade points. We know she's taking 16 credits, so we'll just divide that. And it looks like she's going to need 2.96875. And we've been rounding GPAs to the nearest hundredth. So even though this page doesn't say it, we'll do that. We'll round to the nearest hundredth. And we'll look one space to the right. That's 5 or bigger, so we're going to round this up. And this semester, Amy's going to need a 2.97 in order to bring her GPA up to 2.5. Very similar to what we saw with the exams scores last week is, so she's sitting here at 2.35 right now. Her GPA doesn't have to go up very much to get to 2.5. You're telling me she needs basically to have a 3.0 this semester just to move up that tiny little bit? Yeah, I am. And it's because this 2.35 has 50 credits of weight tied to it. So this 16 credits can help pull her GPA up, but if she wants to pull it up quite a bit, she's going to need a pretty high GPA this semester, a 2.97. Are there any questions on what we did on that one? Hopefully it felt really familiar. It was a little more complicated with the numbers, and we had this extra step down here at the end where we couldn't just stop and say, this is how many grade points she needs. It's what's the GPA she's going to need. We leaned heavily on this formula right here to answer a lot of things in this question. Okay, outstanding. Those are pretty challenging. So if you're comfortable with that, that's great. That's really great. Something else that weighted averages are used for is grade calculation. And this is something that, again, as a teacher, you'll probably be involved in. In Lacey's math class, homework counts for 25% of her grade, quizzes count for 30%, and exams count for 45%. If her scores are as follows, what's her overall percentage in the class? And so essentially what we're doing here is we are using these different weights to calculate Lacey's grade. Weights like this can be valuable as a teacher because going into the semester, you may not know how many homework assignments there are going to be. You may not know how many quizzes there are going to be, and you may not know how many exams there are going to be, especially elementary school. These things might just kind of pop up and you kind of pivot and change. At the college level, we don't really have that much freedom with this. We need to have a syllabus that's extremely structured at the beginning. But K through 12, you might, we need another day on this, so we're going to do another homework. And you don't want to do points then because now you've goofed up all your points. But if you know you want homework to count 25%, no matter how many homework assignments we have. We want quizzes to count for 30%, no matter how many quizzes we have, and exams to count 45%, no matter how many exams we have. So you don't have to worry about points, you just worry about percentages. So with those scores and those weights, let's figure out Lacey's overall percentage in this class. What we're going to do first is we are going to find the mean score for homework, quizzes, and exams. That's the first thing we're going to find, is we're going to find the mean of each of those. So here in homeworks, we need to add those up. Let's see. 100 plus 80 plus 0 plus 85. So that's 265 total points divided by, and here's something you got to be careful with. The 0 counts. So we don't want to say there were just 3 homework assignments. That was one of the assignments. Lacey didn't turn it in, so she got a 0 on that one. So there are 4 homework assignments, not just 3. So we'll divide 265 by 4 and get 66.25. So that's Lacey's homework grade is 66.25. That's going to count for 25% of her overall grade, and we'll see how to handle that in just a minute. Same idea with the quizzes. We'll add those up. 90 plus 72 plus 90, that's 252, divided by 3 this time because there were only 3 quizzes. And that's 84 for a mean quiz score. And then there's only 1 exam, so the mean exam score is 85. So now we've got all the information we need. Now it's just a matter of, okay, how do we manage the weights involved? And the way we do that is we just multiply. We're going to 25%, we're going to rewrite that as a decimal, which will be 0.25. 30%, we're going to rewrite as a decimal. That's going to be 0.30. And 45%, we're going to rewrite as a decimal. That's going to be 0.45. And we're just going to weight each one of those mean scores according to the percentage that goes along with that mean score. So her overall grade is going to be 25% of her grade, or 0.25, is a mean score of 66.25. Gonna have enough room. Let me start over down here. Sorry about that. Her grade is going to be 25% of her grade is a 66.25. And so we're going to multiply those together. 30% of her grade is an 84. And 45% of her grade is an 85. And that's how we take care of these weights. 0.25 times 66.25. We multiply the percentage times the raw score. Percentage times the raw score. Percentage times the raw score. And then we get some points for those. So 0.25 times 66.25, that's the number of percentage points she gets towards her overall grade from homework is 16.5625. We don't want to do any rounding until we get to the very end. 0.3 times 84 is 25.2. And then 0.45 times 85 is 38.25. And now we'll add all these together. So we have 16.5625 plus 25.2 plus 38.25. And overall, we've got 80.0125. Everything we've done today, we've rounded to the nearest hundredth. Let's just go ahead and stay consistent with that. We'll go to the hundredths place, look one space to the right, that's for lower. So we'll round this down to 80.01%. So with those scores on homework, quizzes, and exams, with these specific weights for homework, quizzes, and exams, Lacey's ended up with an 80.01. If she was trying to get a B in the class, boy, did she do that perfectly. Are there any questions on what we did there? Find the mean for each category, multiply each category by its weight, and then add those together to wind up with the overall percentage.